Finish this first.
Gosh, you're gonna stay there like 30 minutes, an hour later, like it'll be time to go. Finish. Finish now. Finish it. That was the one game that was made rating on games because of that one game.
Yep.
And kids don't really care about the ratings, so that's their parents like.
Okay. Number 6.
Back then it was an arcade machine.
We're in 2.5.
2.5. We are ready for this. I'm gonna like hate Wednesday because I gotta dress up for the stupid discussion meet next week.
Alright, we're still in applications of lines. So these questions are kind of related. Yesterday, somebody plotted a lot of dots. We found out the optimal line that models these dots. What's the line to approximate any mid value like 925? You want to find out, you need a model for it. We'll finish this question. The next question is kind of similar. But the problem is nobody made the dots for you. So first part is kind of long. You need to plot all these values into your plot paper, graph paper. Okay? So I'm not sure if you can do it, how quick I can do that because there are 10 values here. So basically you're gonna find x33 if this is 100, 33, 8 is here, 68. By the way, which one is this one? Seems like this one is wrong. 68 is more like this, and 8 as well. No, it's correct. Just need to lower it a little bit. So you're just gonna sketch all these like that. 118, 14 is 118, a little past 100. 14 is really down here. 338, 338, 28 is that.
Would 14 be above 10?
Yeah, I was just testing you guys watching or not. Okay. Good, good observation. So you're saying it's somewhere here? More like that? Okay. How about 338 and 28? Has to be up near 30, right? Good. So because the reason I'm showing this is probably you're gonna work in a research project eventually, wherever you work. You're gonna collect data and you need to plot these. And this is again, what is this data about? It's the okay. There are some animals here. I picked some animals. You guys have majors related to animals, maybe. It's interesting, right? No. By the way, does this mean pregnancy period? Okay. I just want to make sure. Okay. So rabbits stay pregnant 33 days and live about 8 years. Goat is 140. Elephant looks like almost 2 years, right? 1.5 years, and they live 38. So interesting data. So we're just trying to find the relation line between these dots. 58, 10. 58, 10 is midway, a little bit to the left, right here. 112, 12. 112, 12 is here. No, I missed this. Which one was this? Okay, I missed one of them. Yeah, this one. 118, 14. Which one is this one I plotted? Yeah, this is 58, 10. Wrong. Okay, 112, 12 is here. 145, 15. 580, 38. Way up there. Right? 580, 38. Okay. I hope the system is a little forgiving. Let's check. Hold on. Let's check. Anyway, I probably messed up somewhere. But you see how these dots are lined up, correct? You pretty much have the idea. Okay. Now, can you imagine a line passing through these? That's what our line model want to be. Y equals mx plus b. Okay? So, I want to go to the next part. No, I don't want to try again. It's too much time consuming. They say model that line using these two dots. 68, 8, 145, 15. Pretty much the same thing we did yesterday. We will find the line equation between those 2 points. All right, can somebody memorize these? 68, 8, 145, 15. Oh, it looks like they are using these two. 58, 8. No, 68, 8. Which one was it? 68, 8. So they used this dot, and what was it, the other one? They used goat and a fox to relate pregnancy and longevity of animals. Okay. How? You need a line equation, Lx, or in other words, y equals mx plus b. Well, to write a line equation, we need the slope first. Slope is rise over run, correct? Rise is the difference between y coordinates. So I subtract 15 and 8, which is 7. Run is the difference between x values, which is 145 and 68. Perfect, thank you. And the slope is 1 over 7 then. Okay? 77 is the difference of these two values. 1 over 7 is the slope. Now you have one value found out in the equation. The only thing else missing is b. You get the b, you're done. And to get b, you use any one of these points, substitute x and y values, and solve for b. So which one has smaller numbers? This one, fox, 68 and 8. I will substitute. 68 going into x, 8 going into y. Maybe we should have picked 145. No, it's not divisible by 7. I'm trying to pick something divisible by 7, but neither of them is not. So this is 68 over 7 and 8. All right, to get b, we need to subtract 8 and 68 over 7. And that will be 56 minus 68 minus 12 over 7. Set the common denominators, etc. 7 times both sides, 56 minus 68 over 7, which is minus 12 over 7. Okay, that's it. Your model is ready. This is going to compute pregnancy and longevity of all animals you wish. Okay? Such as put a pregnancy value of 50 here, whichever animal is pregnant for 50 days. You can get its longevity approximately with this model. All right? Let's try this on. What's wrong with today? This. Minus 12 over 7? Oh, because they want us to approximate this to 2 decimal places and slope to 3 decimal places. So we need to meet their demands. 1/7, please approximate 1/7 to 3 decimal places. What is 1/7? Come on, take a calculator. What's that? 0.143 x. All right, approximate the y-intercept to 3 decimal, please. 1 point
What was the fraction?
minus 12/7.
1.7.
1. Did you round off?
Dun, dun, dun.
Make me do this.
Round the
Come on.
slope to 3 decimal places.
All right, let's see. 3 decimal places is 143. So that part is right. 12/7. How many decimal places was it?
2.
171 then. All right, seems right. Then we have a mistake in the calculations. 68.8, 145.15.
7 divided by 77 is equal to 7.
There you go. So you knew this whole time, right? You've been watching for us to fail, right? Okay. And of course this will be wrong then. You need to fix the other one as well. 68/11 . 88 minus 68 is 20/7, positive. Am I right? 20/7? Okay. Two, 8, 6. One over 11. What is it? .091.
That's 0.99.
All right, last call. Any mistakes?
Instead of being over 7, shouldn't the y coordinate be over 11?
Thank you. 182. Any more mistakes? One 181. How is it 181? It should be 182. It's 2 decimal places. I don't know. It's their mistake. 2 decimal places. We did 2 decimal place round off. It should be 182. Okay. If something like this happens, let me know in your homework. I'll give you credit. Okay. All right. Let's interpret what this means. So you found a line. This line, when you graph it, it's going to make a line through these dots. So it's going to form a line like this. And it's an upward going line, right? How do I know it's upward going? Yeah, the picture shows that besides slope is positive. What is the slope we got? 1.09. So it's a positive slope, slow but positive slope. So we know things are increasing when you go to the right. So when pregnancy day increase, longevity increase with the slope, which is 0.091. Longevity increases at a rate of that 0.091 years. Is it each year though? Is it 1 day increments? Yeah, this is days, right? This is years. So 10 years, 20 years is Y, so 0.091 year per each day. Alright, except the second part, and first part, we got question done, partially. Okay? Any questions? So I just put this to show another, maybe related to some subject related to your area. It's not any different than what we've done in problem number 5. Okay? Now we are going back to 8 main functions. I ask you to memorize their graph and their equations. Linear functions of straight lines. And this is also a linear function straight line, but it's a special one. It's identity, but because it has only x, y always become equal x. Every number turns it into itself, -2, -2. Quadratic function x squared, x cubed. Do you recall that? This was in 2.6. Square root, cube root, absolute value, and reciprocal function. 8 functions. What are we going to do with them? There is a graph made here for you. Somebody made an experiment again, put the dots. Okay, and what is this experiment about? Flu cases on a 25-day cruise. In 25 days, the number of cases, as you see, increases. In day 0, the day you landed the ship, there are 3 people already sick. And then the next couple days it becomes 6, 8, 15, and then at the end of the day almost whole ship is sick. 18 people. I don't know how many people, but 18 of them are sick already, okay? So, it just says, can you find an equation for this line curve? Can you find an equation for this curve? Because it's not straight line. It's not straight anymore. You cannot get to the points and get the slope and find line equation. This is a curve. Using one of the 8 graphs I gave you, which one is this most similar to? Square root, right? Look, which one is it in the list? It's this one. Okay, I want to transfer this down to the next page. Look, it goes 0, 0, 1, 1, and then 4, 2, and then 9, 3. These are significant values. So let me plot it here so you can compare them. So regular square root function starts at 0, 0, and then you plug in square root 1, it becomes 1. Here is 1, 1. You plug in 4, it becomes 2. Here you go. You plug in 9, it becomes 3. Where's 3? Here. Look, it's quite slower than this, right? You plug in 16, it becomes 4. 16, 4 here. I can do 25 as well here. 25 becomes just 5. There you go. Here's the graph of root x. As you see, if you try to model this situation, flu cases numbers, with this function, you are wrong. You are quite off. Because according to this model, at the end of 25 days, you must have only 5 people sick. This says 18 people sick. So you need to modify this function, stretch it maybe, shift it up, down, left, right. But you need to fit this curve as much as you can to blue one, so you can have a better approximation. So what do you think? What kind of manipulations you can do here? You can add, multiply, subtract things. And this graph is gonna get closer to, hopefully match, 100% match to this one. Our goal is to get 100% match. Add 3 is a good start. So when I add 3, this point becomes 3, 0, so they are aligned. This point becomes, this was 1, 1, it will become 1, 4. So it's gonna go up here. This will become, this was 4, 2, it's gonna become 4, 5. 4, 5. And this will become, this is 9, right? 9, 3 will become 9, 6. Well, adding 3 gets the first numbers matched, but they are still separating. They are not quite fit. So this is root x plus 3. No, they are not matched yet. Any more ideas? You need to lift the tail part really up. Adding 3 is only gonna move it up a little bit. If you add too much, this time this part is gonna be off screen on the top part if you add too much. So you better think multiplication maybe to stretch it up. Times 2. Okay, let's try times 2. If I do times 2, what is this point? 25, 5. It's going to be 25, 10. It's going to move up here. It's still quite short.
So times 5.
Times 5 is gonna make it 25. You're way up. Go a little bit down. Times 3. Times 3, it's gonna move this point into 15. So 3 root x is gonna make 16, 4 into 16, 12. Where's 12? Here. And 9 is going to move into 9. 3 is going to move into 9, 9. Where's 9? Here. This is 9, 9. And 4, 2 is going to move to 4, 6, because 2 times 3 is 6. All right. 1, 1 is going to move into 1, 3. Here. 0, 0 is going to stay at 0, 0. All right, you are close. Now let me delete the old one. I no longer need this. You are close, but not exactly. Again, this point is 16, 18. No, what is this? 16, 15. And this is 16, 12. 25, 18 is this point. This is 25, 15. This one is 9, 9. And this one is, this is 0, 3. By the way, this point is for this green one. Alright, it's not exact fit yet. But this gives me an idea. 15, 12, 18, 15. This is 9, 12. 9, 12, 9, 12. And this is 9, and this is 6. Should be a little to the right. So this is 4, 6. This is 4, 9. There is a difference of 3 between these 2 points. The current equation is root 3x. So how do you close the gap? I need to lift this one, look, lift this black dot how much up so that they can match? 3. So this is a gap of 3 all the time. So I need to lift things up 3 and they will match. So this equation is 3 cube square root of x plus 3. You found it. And it's a perfect match. Okay? I mean, in real life, this is never going to happen. Always some of the dots will be out of the perfect match, but you can still get close. Okay? Now, with this model, you can see what's happening after 2 months. In 60 days, you plug in 60 and see how many people are dead. Okay? Or sick. Square root 60 times 3 plus 3. You're going to get probably 40, 60 people. Okay? All right, that's that. This question was about it, and they gave you some sample basic functions. We already went with square root t. Square root t is the right model for this data. Where's the check tool?
Is that the only part of the question?
Maybe. That was your idea.
I don't see anywhere to put anything else though.
No, the data, but I have to write the whole thing. I have to transfer this. Yes, you're right. 3 square root 3 plus 3. Something is wrong today. I'm getting all questions wrong. Because I'm rushing, you see? Even when I rush, I make mistakes. So slow down, okay? Look how dedicated I am. I'm just trying to send you home early for Thanksgiving. Okay. Okay. I can just cancel class, right? What if I
Yes. You really
Okay. This is 2.7 applications of piecewise defined functions. Piecewise, as you understand from the title, there is a piece of curve or line glued to another curve or line equation. And they kind of patchwork. They patch 2 pieces to make a whole new function. So the more pieces you have like this, the more patches you will have. Okay? That was it in 2.7. Question here is, this is a really good example because most people work for base salary plus commission. You'll probably work like that. And we just want to find out a function to compute this guy's salary at the end of the month according to his sales. So what is the story? This guy makes a base salary $2,000 per month. So if he doesn't sell anything, he doesn't do anything but just sit in his table, he's gonna make $2,000 and get 5 next month. But he's gonna make it, okay? Next, he's rewarded though if he passes 20,000 in total sales. If he passes anything extra, more than the keyword, more than 20,000, brings 6% of the sales as a commission. Anything over though, not the total sales, over. That's the key. Write a piecewise defined function to model the salesperson total monthly salary as a function of the amount of sales. Alright, there isn't much to do in this question. All you need to do is move what's given into the boxes. So, this is the salary you're gonna make at the end of the month, and you won't see any more than $2,000 if you don't pass $20,000. So you will definitely make $2,000 here if what is the case? If your sales, X is your sales amount, between what and what? Between all 0 and 20. If you don't pass 20,000, you will make this. But what is the right choice? Shall we include 0 or exclude 0? 0 means no sales. Question is, when you do no sales, 0 sales, do you still get 2,000 or not? Do you? Yes, then you need to include it. Include 0. Okay, when you sell $20,000 worth of material, goods, do you still get that 2,000? Then we need to include 20,000 as well. So the right choice here is for sales 0 up to 20, 20 included, 0 included, you still make 2,000. This is not interesting part. It's just we just transferred the percentages, right? Base salary up to 20 is this. Now things get interesting after 20,000. So let's first choose the range. For values, blah blah blah, you're gonna start making extra money. So what is the right choice here? Is it X less than 20, sales less than 20? It's this. For 20 or more, you're gonna see some extra cash. Is that right? We already had 20,000 in the first spot. So you cannot include the same X value in both spots. So we need to start exceeding 20,000. Don't include 20,000 on this spot. Okay? Because if you include 20,000 into both spots and say, ask somebody to compute as to 20,000, which one is he gonna use? Top or bottom equation? He needs to make a choice. So we already made the choice for the top one, use that one. Okay, what is your salary though if you pass 20,000? This one requires some algebra. Okay, X is how much you sell, and it's more than 20,000 now, and you are making 6% out of it, right? So I'm going to multiply 6 by, I'm going to take 6% of this. But in math, that sign doesn't make any sense. We turn that sign into 100. So you are adding 6 over 100 of any amount passing 20,000. So this is the amount. I'm multiplying by 6 over 100, and I already made 2,000 before, and I will add them. Is that correct? Is that right? This is incorrect. Where is my flaw, logic flaw?
Is this the amount over 20,000?
Yeah, I took the 6% of entire sales and say only amount over to 20,000. So this X is already more than 20,000. I have to subtract 20,000 from it and compute the exceeding value. Then take 6 over 20, 6 over 100. So you can take this whole and put it here, or first simplify and then put it. Okay? So that's 2,000 plus 0.06x. I changed this into 0.06. What is 6 times 20? 120 over 1,000 is 1,200. 1,200, right? Okay. Now subtract 2,000 and 1,200. That is $800. So I cancel this and make 800. All right. So this is how you compute your salary. First, at the end of the month, they bring you the total sales amount. If it is less than 20,000, this is what you earn. If you see some digits more than 20,000, you multiply those digits by 0.06x and add 800 to it. Like if you sell 100,000 worth of goods, you're gonna get 6,000 plus 800 more. 6,800 is gonna be your salary. Okay? All right? Any questions? All right, so we got. I'm not surprised. Where is the mistake? Yes? Did I multiply this right?
Is it 1,800? You just have 800?
It's 800, right? 2,000 minus that.
That'd be 900.
Hmm?
900.
Is it 900?
If you have 12.
2,000 take away 12. 20 minus 12 is 8, right?
18. What is it? 2,000 minus 1,200. Is it 20,000 minus 1,200? No, it's you told me 2,000.
$2,000 is your salary.
Where do you get the 1,200?
6 over 100 times 20,000. I just multiply 6 over this. Let's try this. It's 800. Still wrong.
Do you have the wrong
Do we have to sign this?
sign?
Maybe. Are we reading this correct? 20,000 in total sales, so up to 0 to 12.
Well, do you need the equal to?
20,000 here, it's the extra commission, so 20,000. Oh, maybe. I might be thinking of that wrong. You might have to change the desk. Let's just get it wrong and see what it says.
Yeah?
You
Good
gotta change
idea.
number.
You have to change
Yes,
something every time before it can.
Oh, you guys are an expert in this.
Well, it's on exams, you could fail the same problem 6 times and then just finally get it
All
right.
right. Okay. It's not our mistake. It's not.
That looks like
Yeah, you
16
needed a
or
less than or
more.
equal to somewhere.
No.
No, he just wasn't supposed to multiply.
That looks like what I said.
Supposed to be like the whole class.
Well, it looks like we had the signs wrong.
Sign, they didn't include 20. Hold on.
That's so stupid. Oh.
It's impossible.
Your X.
When he reaches 20,000 in sales, he starts earning commission. Maybe the wording says 20,000 should be included here. But at least we got the formulas right. So this is not a major mistake. You can include 20,000 to the first or second, but don't, as long as you don't include into both, as long as you don't, you include in one place, you're fine.
It includes both in the answer.
They didn't. Look, they excluded 20 here, included in here. As a matter of fact, what happens if you include 20 here, as we did, as they did? Plug in 20 here, it's 1,200 plus 800. You still get $2,000. These two match, right? Okay. So don't multiply this out as we did. We simplified it. Maybe that's one mistake, and they didn't wanna, because of the wording says he reaches 20 in total sales, he starts earning commission, so they included 20 into the second one. So that's what you should do too. Okay? Yeah, I don't like application questions. Alright, we'll do one more application. You're selling tickets to a show, River Dance. Have you seen it? No. It's $50.
Waste of time.
If you sell X many tickets, $50 each, 3-second question, what is it? 50X is your cost. You need to spend $50 each, X many you're selling, and that's your cost of purchasing tickets. But it's not that easy. There is a sales tax and a processing fee now for group tickets. You need to compute now your amount you spend on the tickets, including tax and processing fee of $7 now. So we need to add tax to each sale now and fixed constant $7. All right, what do you think? We're still buying them $50 each, X many of them, or A many of them. They changed the variable to A. Okay? But how do I, now this is how much you still pay. There is no discount, right? They give us a discount? There is a tax? No. No, this is just for tax. $8 spent on tax. Okay, this is easy. This is not what they asked. A is not the number of tickets. This is A is amount spent on tickets. And how much did you spend on tickets? A amount, okay. But what is the tax amount? This is the amount you spent. I don't know how many tickets you got, maybe $2,000 worth. You plug in 2,000 here, but we need to first compute tax here. Tax plus you need to have a processing fee as well. Well, processing fee is independent from the amount spent. Even you purchase one ticket or spend $50, they will still charge you $7. That's constant. I need to know the tax. Amount is A, and how do you compute 3.5% of A? 35 over 1,000, or 3.5 over 100. Or let's change it into decimal, best option. 0.035. Okay? So this is the tax amount. This is again total cost for $8 spent on tickets is we are missing something. What is it? This is tax. This is processing fee, but you didn't pay for the tickets. How much did you pay? No, A amount you spent. Because we don't know how many tickets you purchased. It's called A. This is the tax on A. This is the processing fee, but there is also purchasing spent money. So can we add these two? They are like terms, 0.035 and A. It will make 1.035 A plus 7. Okay? Any objections? Are we good, correct? Good. Next, we are going to compose these two functions. Do you see that little circle? Okay? Because here is the situation. We don't know how many tickets we got. It just says, here is $2,000, compute the tax and processing fee on top of the spend. And this function only tells you if you spend $2,000, what's your total cost is. We don't know how many tickets we got. By composing these functions, this is what's going to happen. Somebody is going to order 50 tickets. You will first compute how much you spent for 50 tickets, and then they will process tax and processing fee on that 50 tickets purchased. Do you see the difference? This only computes ticket prices. This is the processing and tax fees total. But when I compose those two functions, you enter the number of tickets, you compute the amount you spent first, and then that spent money is going to be taxed and processed with $7. That function is going to give us whole thing together. So we will compose these two functions, TOC, which means X will go in C first, and we will compute this, and it will come and be processed in T function. What is C of X? C of X is 50X, correct? 50X. I just copied this guy here. Now 50X is going to be processed in T. Just imagine 50X happens everywhere. 50X and 50X. And there you go. That's your total amount. Actually, right here, 50X. So 1.035 times 50 is, what is it? Thank you. This is the total cost per each number of tickets you buy. Now, it's probably because of this. All right. Now you're buying 6 tickets. Can you compute how much you're gonna pay for 6 tickets, including cost of tickets and tax and processing? All you need to do is, instead of doing these two separately, you need to first put 6 here, compute amount spent in first, and now you will enter it into second, that amount spent, and get the whole thing. Instead of doing 2 separate work, now you can use the compose function, plug in 6 here, 6 tickets, multiply by 5175 and add 7. That will be how much your total out of pocket cost for 6 tickets will be, and which is, anyone?
$317.50.
No, it has to be more than that. 17? It's $51 each times 6. Should be 300? Maybe
17.
Okay,
5.
that's it. So this indicates the total cost to purchase 6 tickets is $317.50. All right, there you go. So this is a good example of where composition of functions are used. There are 2 functions doing separate things, but if you want to do it all together, you compose. All right, sorry, but I'm still early, a couple minutes.
You never marked me here in attendance.
You
Embryo.
Emma.
Embryo.
Embryo.
Top, middle.
There you go.
Thank you.
I'm here as well.
You are
Mariah.
Mariah.
And Bobby goes. And Bobby